Hey everybody, welcome back to Off the Grid Tiny House. We're on day 26 of our 50-day challenge. If you want to learn more about that, check out our intro video. In our last episode, we started the installation of our rough electrical, and in this episode, we're going to finish it up by making up the wires inside our boxes and wiring up our main panel. For those of you who've been enjoying the videos and watching on a regular basis, you will notice a little change moving forward. My wife and I have a baby on the way. We need to get the tiny house finished a little quicker than I thought. And also, we haven't really gotten the amount of subscribers I was hoping for to help finance the channel. So in the interest of time and budget, we're gonna kind of make the videos a little less editing, and there might be a little less information. We'll try and get as much as possible and try to show you everything, but there's just not going to be as much detail moving forward. So I just want to make you aware of that change and hope it's still a valuable resource for you. So even though our episodes are getting simpler, I still wanted to take the time to finish up electrical and give you a really good idea of how the electricity flows through the tiny house and how that all works. So I'm going to take you around and we'll look inside some of our switches and some of our outlets and look at how I'm putting the wires together there so that electricity flows properly through them. So appliances are really easy. Here we have our dishwasher wire, and so it's going to pick up a circuit breaker here. The black wire is going to be attached right here to the circuit breaker on the hot, and it's going to travel down here. You can see that wire. It's going through the wall, and it's coming all the way up top, and then it's coming down here, and it's coming right here, and this is where our dishwasher is going to be. So again, we got a black wire, white wire, and a ground wire in there. The black's going to connect to the dishwasher, and then the white will also connect to the dishwasher. So the electricity goes into the dishwasher, and then it loops back around the white wire, and it comes all the way back through our white wire here, which connects to our neutral bar, which connects to our neutral lug here, and exits the tiny house and back to the power company. Very simple. Now lights are a little more complex. So we're gonna follow, this is our lighting circuit. Lights use very little power these days with LEDs. So all of our lights are on one circuit except for exterior lights. So we're starting here, and you can see this first wire, it comes up and it comes down over here. And I've labeled one of these power in. So from our panel, we're getting power right here. Now we have two more wires. One is power out. That's going to go to our next lighting circuit. And now this is actually going to go to the light. This is a switch box here. So we're going to have a switch here that operates the light that's right above. So when we make up this box, first we're going to strip the wires. We're going to strip them all the way back, almost to the inside of the box. Just going to leave about a 1/4 inch. You notice how each one of these wires is entering through a separate location in the back. And you can see I'm just kind of marking these because I'm going to take off my label now. So I'm marking them power in, PI, power out, and then I'm going to remember my light is on this side. So just so I can keep track of everything. I'm just going to peel back the protective insulating layer. Also, the ground wire is covered with a little brown piece of paper. So we're going to cut that back, and we're just going to cut all of that off, making sure that we don't cut the insulation on these wires. The first thing we're going to do is tie all the grounds together. No matter where it's coming from, if it's coming from the light or there's power out, which is going to the next box, we want it to eventually go back with this power in ground and go back to our panel box and get grounded. So we're going to tie them all together. And what we're going to do is use a crimp ring to do that. So this just slides on, and then we're going to cut all but one, because once they're tied together, we only need one to come out. We're going to do the same with our neutral wires, because again, no matter if the power is coming from the light bulb that is the switch, if it's coming from the light bulb, or if it's coming from this next light circuit, we want it to, all the neutral power is coming back from the light. So it's going back to the panel. So we want it to go to the power in. So no matter what it is, it's connected to this power in neutral and it's going back to the panel. So we're gonna move this out of the way and we're just gonna tie all these together, very simple. So we're gonna cut them all back a little bit. And we'll strip them. All right, you can always check, take this off. That's what you want to see when you take it off. Notice we got a really nice connection there. I'm just going to tuck that back. Again, this is our light over here. This is power in from the panel, and this is power out. So power in and power out, we're going to tie together because we always want, for this next box that this is going to, we always want it to connect it to power. However, we don't always want the light connected to power. We want to have a switch here that connects it. So we're going to leave this off and we're going to connect these two together. Again, we're going to cut these and strip them. And we're going to strip this one also. And we're going to make what's called a pigtail. Whenever we're connecting two wires together and we want another one to continue, kind of like we did with the ground, we can't use this crimp ring with the one we used with the ground wire. We can't use that with these because they're insulated. So what we'll do is we'll use this pigtail here. That's all ready for when we do our finish electrical. Each box has numbers in it like you see here, and that tells you how many of each wire you can fit in. So these are 14 gauge wires, and the number that we have in the back of the box here, 16-14. So we can fit 16 of these wires, but these are not wires, these are cables, because they're a bundle of wires. So each of these has 2 wires in it. The ground is not counted. You're allowed to take all the grounds and count them as one. So this has 2 wires, 4, 6, 8, 10. Plus all the grounds is 11. Now you also need to count two wires for each switch. So that's 13 and 15. So you can see we're just under the limit here. So very useful to use these big boxes. It's kind of like hubs where a bunch of circuits come in. So we can see here, first we have our power in from the circuit we just wired, power coming in, and then we have power coming out to 2 different light bulbs here, 2 different switches, 2 other switches. One of them is our under cabinet lighting, and the other one is our bathroom sink vanity. So just like the other one, these are all going to get tied together, the hots. And then with these are our 2 switches. We're going to have 2 switches here, one for the exterior porch light and one for the main living area kitchen lights. So same thing, we're going to start by stripping the wires. Now this time we have 2 switches, so we're going to leave 2 of these long. One for each of our switches. That way they can both get grounded. Once again, we'll tie all of our neutrals together. Now, one thing to keep in mind with the neutrals is we're only allowed to tie all of these together because they're all going to be on the same circuit breaker. So sometimes it happens where you have a box where you have wires on 2 different circuit breakers coming through, and if that's the case, you need to keep those neutral wires separate. But all of these are part of our lighting circuit, so they're all on the same breaker. We can tie all the neutrals together. Now we need our 2 light switches, which is, this one is the porch light, and this one is our main light. And these 3 is our power in and power out. So once again, we're going to tie these together with a pigtail. actually with 2 pigtails. So a lot of our wires are going to come out of boxes like this, but sometimes we have some just coming out the wall here. This is for our under cabinet lights. So it's not going to have a box, it's just going to plug in directly to the light. You'll notice that when we do our finished electrical, but so we're just going to leave a little bit of wire hanging out here, and when we put our drywall, we'll just put this out a little hole in the sheet of drywall. All right, so next we'll do this one. This is another counter receptacle. So why do we have 2 wires? Well, power is coming in on one and going out on the other to the next receptacle. So you see they're all chained together. So the power starts at the panel and it hits our first receptacle right here. Then it goes to our next, and our next, and our next, and our last in the line, where it loops from the hot to the neutral and then makes its way back on the neutrals, right? So we're making that loop. So once we have it wired up, we'll attach the outlet, and we'll attach both hots, both neutrals, and the ground all attached to the outlet. So they're all wired together. And anytime you plug it in, it will get power to the receptacle. So this is a lot of wires here, but basically what we have going on here is these would be double outlets for computers, and you can buy like special surge protected ones. So instead of having that strip, you can have a surge protected double outlet, good for plugging in computers, printers, etc. And then up here, this will be, the table height will be like right here. And so these will be like USB-Cs, so you can just plug in your phone, and you don't need any box to plug in the outlet. You can just plug in the USB. So with this one, all this is a light. You notice on the other side there's matching office lights. So this is kind of like our office area table. So all this is just a light bulb. This will be a light fixture. And so there's our switch for it right there. But we've got a couple extra wires here. And the reason is because I was running low on wire, and I wanted to run power from the outlets down there to this. This is going to be our internet, our Wi-Fi. So we need power and internet both right here. And this wire just couldn't quite make it. It was close, but it wasn't going to make it. So rather than just get a whole new piece of wire, I just stubbed out. There was this box right here, this light box is here, and so I just stubbed out of here, and then I could use another wire just to finish that last little leg. So we're just going to tie these 2 together, and then this is just our light switch. The one thing about that is when we do that, we do not tie all the neutrals together like normal, because they're 2 different circuits. So this one is just going to stay, and we will attach the neutral to the light bulb neutral. And these are going to get tied together. The neutrals get tied together because they're on the same circuit. But this one is our outlet circuit, and this one is our light circuit. So to put our exterior boxes, first we want to start on the inside and make sure it's lined up on a stud. So we have a stud right here, and then I marked the spot and I just drilled the hole just like we did the windows. You drill a hole to start in each corner, and that kind of gives you a reference point of where to come outside and use the jigsaw and cut around. And then you put the box in, run the wire out, and then we have here electrical flashing, and this just slides in a slit that we cut right up here, and it wraps right around the box there and just gives us a really nice waterproof. You can see there's no way anything's going to get into that box. It's going to run right down our weather resistant barrier and our flashing sides. So we still got a couple circuits to go, but you can see every single one of these wires is a different circuit that's going to connect to a circuit breaker on our main panel here. So here's where our power's coming in, and this will just close over there, and we're going to just use some plumber's tape to really secure this good so it's going to stay in place. And then we'll tighten up this wire a little bit more. And you can see how that's running across here and up to our panel. And this is where the power enters the panel. So first thing we're going to do is screw in our ground bar. Now for a main panel that's connected directly to power company, you can just put your ground wires with the neutrals. But because this is called a sub panel, because it's not hooked up to power company, it's hooked up to another panel with its own breaker, the grounds have to be on their own bar. So these always come separate. Sometimes you need to buy them. This one came with the panel, but you need to attach it on because sometimes you don't use it. So when you do need it like this, you have to screw it on. So we're just gonna pick a spot like up here. You can see here for our bigger breakers, they're gonna go across this side and this side. See, they're gonna hit one of each. When you put a breaker in, you're just gonna slide this side in first, lock it in place, and then push this in. These extra long breakers here are called arc fault circuit breakers. And for building codes, they require them. It's just an extra safety feature. So for arc fault circuit breakers, we're gonna connect the neutral wire and the hot wire here. So the hot wire will go in this hole here, and the neutral wire will connect here. And that neutral wire is connected to these here. So you can see how that's going to wrap around the neutral bar. So the neutral wire is kind of attached to the neutral bar, but it goes through here. And inside here is a little processor, a little tiny computer, and it senses if there's an arc somewhere. So it'll sense like electrical current wave, it'll sense like a little anomaly in the electrical current wave, and it'll trip the circuit breaker. It's called an arc fault circuit breaker. So you can see how when we put this on, that clip there is just gonna wrap around the neutral bar. So we're going to strip this down. We want to keep things nice and neat in the panel. So I'll start with the hots. Something like that. So we got two. All of these 240s will get both wires because they're adding them up, right? One thing with these is one time I had one where the circuit wasn't working and it was for a stove, and it was because the screw was going down on top of the insulation. So make sure before you tighten it down that you're not going down on the insulation. You don't want extra wire showing, but you also don't want to go down on the insulation. So that's our first one. So real quick, I just want to go through the just one circuit so you can really get a good idea of how the electricity is flowing through the wires. So you can see here, inside here, we've got our two hots and our one neutral and our ground. As the power comes in, it's going to come in on the red right here, and it's going to hit this metal plate which is connected to this breaker. So once it goes to that breaker, then it's going to continue on the hot wire for lights. And you can see that hot wire for lights eventually hooks up inside one of these, and it makes its way up and over and down to our light switch here. And it comes into here, and it's one of these black wires in here. And the other black wire that you see runs up through one of these wires, and it goes to our light right there. So that black wire there is the one that's here, and those two black wires are going to connect. When you flip that switch, those two black wires connect. And so hot is able to go from our panel now through the switch up to the light. It's going to go through the light bulb, and then it's going to hit the white wire and return on the white. So it's going to return back the same way it came, Now all of our white wires are tied together here, so they're not switched. Only the hots are switched. So it's going to go through that white neutral wire, and it's going to go back the same way it came. It's going to hit the other side of that breaker. And what this circuit breaker does is it just kind of checks that the power coming in and the power coming out are the same, because if they're not, that means it lost some of that power somewhere. It also checks if there's like an arc or like a power surge or something. It just checks to make sure that the power is flowing through that circuit properly. And as long as it does, then this breaker stays open and the power continues to our neutral bar here. So it goes through the breaker to our neutral bar, down our neutral bar, hits our neutral wire here, and returns back to the power company. So I just wanted to take off one of our 240 volt circuits right here. This one's for the heat pump. And you can see how it's connected to these two metal brackets right here. You see that? So one of those metal brackets goes to our black wire here. The other one goes to our red wire. So you can see how the two are connected inside our breaker. So we've got 120 volts on each one. When they connect here, we get 240 volts going to our heat pump. So let's talk about wire size real quick. Now, just like if you have a ton of water flowing through a pipe, you need a bigger pipe. Otherwise, that pipe is going to burst. The pressure of the water flowing quickly is going to burst the pipe. So same thing here. If you have a lot of current, a lot of electrical flow, then you need a larger wire. So you can see up here we have several different wire types, and they're color-coded to help you just look at it real quickly and know which wire is bigger, because the difference between the sizes is not that much. So it helps to have the color coding of the wires. We measure wire size in what's called wire gauge. It's a unit of measurement for wire diameter. So our smallest gauge here is this white wire right here. This is 14 gauge wire. This is good for a 15 amps. So all of those 15 amp breakers, you can see they're labeled here. Any 15 amp circuit, it's going to have this white wire here, 14 gauge. And our next is 12 gauge wire, and that's good for 20 amps. So you notice any of our 20s here we've got one. This is going to one of those yellow cables. Okay, our next one here is 10 gauge, and 10 gauge is good for 30 amps. So this one's going to our water heater. And then we have 8 gauge, and that's good for 40 amps. And this is going to our induction. And then here we have 6 gauge. 6 gauge is going into our panel, and 6 gauge is good for 50 amps. And that's the size of our panel. We have a 50 amp panel. So you can see all those different sizes and what they're good for. The electrical code tells you what size wire is good for what amperage. Now, there is something to keep in mind. If you have a long distance, then you can't use those numbers. So if you're going like, we're actually running this power all the way back to our house, to the panel on the house, and that's how we're getting power in here. But we can't use this 6 gauge wire all the way back to the house because it's such a long distance, and the wire is going to heat up. There's going to be more resistance, and so use a bigger wire. And there's wire sizing calculators online. Just you know, this wire is made by a company called Southwire, and if you go on their website, there's a wire size calculator. You can type in the current, you can type in the distance, and it'll tell you what kind of wire you can use. In our next episode, we'll be installing the HVAC for the tiny house, which includes our range fan, our ERV, and our heat pump. We'll also have a bonus episode for electrical where we go over some complicated subjects like 3-way switches and 240 volt circuits that do not require neutral wire. Hopefully you can check them out.